Good morning, everybody.
Good morning.
How are you all doing?
Great.
Alrighty, so today I'm going to talk to you guys about virtualization. Anybody know anything about that? No? Okay. Well, in the simplest definition, it is the act of creating a virtual emulation of something that otherwise exists. And as you can see, I've got like a real bunny versus one made in some kind of 3D modeling software there. And then a lot of things can be commonly virtualized, 3D objects, basic human thought, like the form of AI and whatnot, computer systems, and you can also emulate networks with virtualization. Mostly I'm going to talk to you guys about virtual machines today, and that is the emulation of a computer system. Some common softwares used for that is VirtualBox, VMware, Microsoft Hyper-V, and QEMU. And then they work. A virtual machine exists and runs as a file on a host computer, allowing a guest computer to use it normally. And as it is just a file, it is easily backed up and safer in that respect. And the host computer can be used to run multiple instances for many different guest computers, and that can be very economical because it can keep costs down quite a bit. The guest computer can be either a thick or a thin client, and it can even be a zero client, but I forgot to put that on there, which is basically how much hardware is needed for it to do its tasks. So a thick client is essentially your standard everyday computer. It's fully equipped with hardware capable of performing its own processing and basically just standard computer there. Whereas a thin client is pretty much just the bare minimum to get it going, and it starts to rely heavily on the host or the server, whatever is supplying the virtual machine. And video for you there.
Virtualization. What's that? The simple answer, virtualization makes one physical computer act and perform like many computers. How? Every computer has 4 attributes: processor, memory, storage, network. So virtualization works like this. Take a big computer with plenty of processing, memory, storage, and network capacity. Install a piece of software called Hypervisor. This physical machine is called the host. The hypervisor manages the physical resources of the host so that the virtual machines can use them as they need to. Guest computers run inside the physical hardware. They act exactly as though they were physical machines, but they aren't. They're just big files. Why would you virtualize? Run many servers on one physical server. Save money on hardware. Upgrade virtual machines hardware with mouse clicks. Disaster recovery. Virtual machines are files, so the entire VM can be backed up. Not just the data, but the OS, installed programs, the whole thing. Want to know more? Contact us for a free virtualization consultation at 352.
Okay. So that video talked a little bit about hypervisors, and that is also called a virtual machine manager. It's basically just the software that manages the virtual machine, of course. And there are 2 types, simply named Type 1 and Type 2. A Type 1 hypervisor is a native or a bare metal hypervisor, and it runs directly on the host computer, and it loads before the operating system specifically. And Type 2 are hosted hypervisors, and they run within the host's operating system. And so as you can see here, it starts with the hardware, and in the Type 1, it's Type 1 is usually going to be like a server or something like that, and run over a network to other client computers through the hypervisor. And Type 2 runs again from a host computer, and then it loads into an operating system before going into the hypervisor itself. And that's typically going to be not really a server, but just kind of your everyday computer. And then there's 2 types of virtualization. You've got full virtualization and para-virtualization. The key difference between them is that in full virtualization, the guest operating system is unaware that it is a guest operating system. And all the hardware is virtualized by the host, and it thinks that it can communicate with real physical hardware, but it can't actually. I've got another video explaining that better.
One idea for this virtualization framework is what is called full virtualization. And in full virtualization, the idea is to leave the operating system pretty much untouched. So you can run the unchanged binary of the operating system on top of the hypervisor. This is called full virtualization because the operating system is completely untouched. Nothing has been changed. Not even a single line of code is modified in these operating systems in order to run on the hypervisor simultaneously. But we have to be a little bit clever to get this to work, however. Operating systems running on top of the hypervisor are run as user-level processes. They're not running at the same level of privilege as a Linux operating system that is running on bare metal. But if the operating system code is unchanged, it doesn't know that it does not have the privilege for doing certain things that it would do normally on bare metal hardware. In other words, when the operating system executes some privileged instructions, meaning they have to be in a privileged mode or kernel mode to run on bare metal in order to execute those instructions. Those instructions will create a trap that goes into the hypervisor, and the hypervisor will then emulate the intended functionality of the operating system. And this is what is called the trap and emulate strategy. Essentially, each operating system thinks it is running on bare metal, and therefore it does exactly what it would have done on a bare metal processor, meaning that it will try to execute certain privileged instructions thinking it has the right privilege, but it does not have the right privilege because it's run as a user-level process on top of the hypervisor. And therefore, when they try to do something that requires a higher level of privilege than the user level, it will result in a trap into the hypervisor, and the hypervisor will then emulate the intended functionality of that particular operating system. There are some thorny issues with this trap and emulate strategy of full virtualization, and that is, in some architectures, some privileged instructions may fail silently. What that means is, you would think that the instruction actually succeeded, but it did not, and you may never know about it. And in order to get around this problem, in fully virtualized systems, the hypervisor will resort to a binary translation strategy, meaning it knows what are the things that might fail silently in the architecture. Look for those gotchas in each of these individual binaries of the unmodified guest operating systems. And through binary editing strategy, they will ensure that those instructions are dealt with carefully so that if those instructions fail silently, the hypervisor can catch it and take the appropriate action. And this was a problem in early instances of Intel architecture. Both Intel and AMD have since started adding virtualization support to the hardware so that such problems don't exist anymore. But in the early going, when virtualization technology was first experimented with in the late 90s and the early 2000s, this was a problem that virtualization technology had to overcome in order to make sure that you can run operating systems as unchained binaries on a fully virtualized hypervisor. Full virtualization is the technology that is employed in the VMware system.
Okay. And then we have paravirtualization, which is where the guest operating system does know that it is being virtualized and is a virtual machine. So the drivers for it are made as such that they expect to obviously not communicate with real hardware, so it just emulates that in and of itself without relying on the hypervisor to do so.
Another approach to virtualization is to modify the source code of the guest operating system. If we can do that, not only can we avoid problematic instructions, as I mentioned earlier with full virtualization, but we can also include optimizations. For instance, letting the guest operating system see real hardware resources underneath the hypervisor, access to real hardware resources, and also being able to employ tricks such as page coloring, exploiting the characteristics of the underlying hardware. It is important to note, however, that so far as the applications are concerned, nothing is changed about the operating system, because the interfaces that the application see is exactly the interfaces provided by the operating system. If there's an application that is running on Windows, it sees the same API. If the application is running on top of Linux, it sees exactly the same API as it would if this Linux operating system is running on native hardware. In this sense, there's no change to the applications themselves, but the operating system has to be modified in order to account for the fact that it is not running on bare metal, but it is running as a guest of the hypervisor. And this is why this technology is often referred to as para-virtualization, meaning it is not fully virtualized, but a part of it is modified to account for being a guest of the hypervisor. The Zen product family uses this para-virtualization approach. Now this brings up an interesting question. I said that in order to do this para-virtualization, we have to modify the operating system. But how big is this modification?
Alright, so the main key benefits of virtualizing is that in setting up a network and everything for your company or whatever, it's a lot cheaper to do it. You don't have to spend as much on the hardware because you can run it with thin or zero clients, and that'll drastically bring your costs down. Then you can also provision your resources faster. It's a lot easier to change the configurations of a virtual machine rather than a physical machine, because well, one, you can just edit the configuration of it, and two, you only have one system to deal with, or well, multiple maybe, but anyways. You also have better disaster recovery again because it is just a file. You can just easily back up the whole system so that if anything happens to it, you can recover the entire thing. Another key benefit is that they are isolated from the operating system and also from other users if they're all running on different virtual machines. And that concludes my presentation for today. Has anybody got any questions or anything about that? All right, thank you.